Hi, everybody. My name is Ilkka Turunen. I'm the field CTO here at Sonatype. And today's presentation is something a little bit different and a little bit more fundamental. What we're going to be doing is looking at how AI is changing how we manage dependencies in software. The way that this got started in the first place was that we were looking at SBOMs just on various different projects to help talk about how SBOMs generally look like. So to illustrate this point, what I wanted to do was go through a open source project that helps us illustrate the point. Really, one of the key things that I've discovered over the years of working with organizations to do software supply chain management is it's very easy to say wisdoms like, hey, over 90% of your software is based out of open source components. But it's very hard to actually visualize what that open source dependency tree looks like. Now, historically, we've had visualizations that have helped us grok this image, 2D flat plane maps. But that loses something in the way, especially in terms of complexity, in terms of dependency trees. So what we did was really try to find a way of looking at the software behind the software that we write and really truly understand the sort of web of interdependencies. So to illustrate the point, what I wanted to do today was, first of all, show you something, show what the open source that powers a very high profile, human-driven open source project looks like. So Spring Framework, which I have open here on GitHub, is one of the most popular Java open source projects on the planet. It's been going for many years, I believe even decades now, and it powers some of the most powerful websites on the planet. Think online banking, think critical services and infrastructure. Spring Framework is one of the most popular Java frameworks out there. So anyone building enterprise software using the Java programming language will probably lean in on this project. And what's really cool about Spring is it has 1,000 of the most talented human developers backing it up, building functionality for it every single day. It's high quality, well regarded, and well thought through. Now, what we can do is we can take the Spring Framework website and we can actually visualize what its open source looks like. And this is what comes out. This is a 3D visualization of every single, not of the code of the project itself, but every single open source dependency that that software uses to power itself. So Spring Framework today has over 820 individual dependencies. The way that this works is that each and every one of these boxes represents a piece of open source that's been pulled in. Now, one of the wisdoms of open source is not that every single piece of open source is chosen by the developers themselves. In fact, developers often only choose 10 to 20 to 30, a handful of open source dependencies themselves. But those dependencies have other dependencies that then pull in other dependencies that pull in other dependencies that make up the total software bill of materials of that unique piece of software. And to understand the complexity of what the modern software supply chain looks like, this is a great visualization that helps us see how each individual open source component pulls in other open source and then pulls in other open source. So in this particular case, if we look at this ActiveMQRA component, we can see that it relies on two other components, which then in turn rely on other components. This is how modern software supply chains are formed. Developers make choices about what extra functionality they need, which they don't want to implement themselves or maintain, or there might be better entities out there. And most modern software relies on a ton of this. This project in on itself, it's a relatively large project, has over 820 components that have over 1,600 related interdependencies in there, and they have over 10 degrees of depth. Now, this project itself is comprised of two programming languages. It has Java components as well as JavaScript components, each of which form their own unique supply chains and relative interdependencies with one another. Now, this is certainly an interesting view. This is not an uncommon software supply chain at all when we look at software, for example, in the enterprise. So it's relatively well constrained. It's well kept in control. It looks like it has got relatively large architectural views. And crucially, the first level of dependencies is fairly compact. This is what most teams would be expecting to see. And even as an engineer, I can logically know that a project might have a large or a standard supply chain, but to truly see it laid out like this in 3D helps us understand and visualize how complex modern software supply chains have come. Now, each of these, of course, don't come without risk. Every single component is a potential liability or at least maintainability issue. And so it's very important that we have a good, solid sense of the potential risks and issues affecting these components. Now, this is a human-driven project. We've looked at what that looks like, and we can certainly take another glance at this, which is a more traditional engineering view. This is a view that shows you the components laid out hierarchically. On the bottom level here, we have each and every dependency that the developer chose themselves. On the second level are dependencies of those original open source components. On the third level, more dependencies of the dependencies, et cetera, et cetera, et cetera. So if we go down the stack, we can actually click and see how how the open source components have been pulled in and what the levels of interdependency there are. It's interesting to be able to see how each and every component relates to one another, how that component then relates to other parts of the supply chain, and how it ultimately cascades down to a dependency choice made by the developer in the very beginning. Now, as engineers, we tend to look at these stack models or tree models a lot more often than we tend to look at 3D visualizations. But being able to see these in 3D gives us a sense of what normal looks like. So let's take our eyes and look towards the future. How does AI change this picture? Most organizations have spent the last 6 months adopting agentic AI development frameworks, adopting agentic development workflows. So to contrast and compare, it's very useful to look at a highly AI-driven open source project. This is OpenClaw. It's one of the most popular open source projects on GitHub right now. It is a project that was originally founded by Peter Steinberger, who built OpenClaw as a way of experimenting, taking coding assistants, which were very passive and prompt oriented, and creating them, making them independent and autonomous so that they could run longer work loops. You may remember some interesting news stories in December about AI Reddit, about AI social media, where AI bots were talking to one another. This is the actual AI project that powered that particular experiment. OpenClaw can be used for anything, as a single personal assistant, to a coding assistant, to various other use cases that various internet denizens have tried. It's also one of the most popular open source projects in region memory in GitHub. It has over 380,000 stars. But a couple of individual characteristics that you notice immediately about this project. OpenClaw is a project that was founded in December of 2025. So it's really been a project at the time of recording that's about 7 months old. In that time alone, though, it has amassed over 62,000 changes onto its main branch because it is driven by AI-based development. They're very much driving this using agentic AI orchestration and coding agents. Contrast and compare that to the human-driven project, which is Spring Framework that has human engineers, where over the decades of its work, it has run about 35,000 changes in total. So within 7 months, an AI-driven project has led to almost a doubling of the commit count of a long decades running open source project. So it's interesting to ask the question, what does this mean for its open source usage? Surely AI agents will write less open source and write more first-party code. Well, if we look at the dependency tree of OpenClaw, this is the latest commit visualized in the exact same way as we looked at the human-driven SBOM. And what we can see is that, first of all, its supply chain is just so much larger than the human-driven project. Now, of course, these are different projects. It's kind of comparing apples to oranges, but it's interesting to see that within those 65,000 changes, they have amassed a software supply chain that is, well, nearly double the size, with over 1,365 dependencies compared to the 800 or so of the human-driven project. What's interesting also is that there are a lot more transitive dependencies in this type of project. And in fact, when we have run audits of open source projects across GitHub, when we look at their levels of AI coding assistance, what we're actually seeing is an increase in open source dependency adoption, meaning that their supply chains get larger quicker compared to comparative human projects. And that has a lot to do with the rate of change. The rate of change is so much faster. On average, OpenClaw has periods where it has one change into their main branch a minute. compared to maybe one or two a day in the human-driven projects. So to see, because the rate of change is so much larger, their dependency trees are so much larger as well. We take a very similar hierarchical view of the dependency tree compared to the supply chain that we saw in the human-driven one. We can see that this really has quite a large first level dependency tree, but really the transitive levels just bulge out of control because each and every one of these projects have so much more dependency trees to give. AI agents don't always have the context of what they're pulling in context of all of the other dependencies. So without proper controls and engineering efforts, it's very easy to let this dependency tree fall out of control. So one of the ways that the future is changing for us is that dependency trees are getting larger. And of course, each and every one of these individual components is a potential security risk. It makes sense from an AI perspective as well. AI agents know of more open source than humans do. So it's easier for them to select open source to support their development because whereas a human might only have a limited memory context of a few hundred open source projects that they know how to use, that they want to adopt and experiment with, and LLM knows of every single open source project on the planet at the time of its training. So it's able to dip into a vaster pool of dependencies that it can then leverage in writing code. Using dependencies as well can be more token efficient. So essentially, we're ending up in a situation where actually open source adoption is increasing. This is also supported by the data that we have seen in our State of the Software Supply Chain report over the years that allows us to measure open source download volumes across four major open source ecosystems. So it's being felt everywhere. And one of the pressures being applied to open source ecosystems, of course, is how do they respond to the ability to distribute open source at this new AI scale that is increasing the speed of adoption significantly. And as developers and as maintainers of applications, we now have to ask ourselves the question, how can we cope with this new scale of open source adoption? And crucially, how do we manage the risk and the software supply chain? Hopefully that's been an interesting demonstration for you today. Hopefully you've gained a little bit of understanding and awareness of what modern software supply chains look like. They're more complex than ever before. They're more multilingual than ever before. And crucially, AI is speeding up the rate of open source adoption. In some other episodes, we're going to deep dive into what does this mean from a risk perspective and how are threat actors leveraging this new future as well. Thanks very much for this. Hopefully it's been helpful.